Okay, this is part 3 where we're trying to get the static coefficient of friction between this aluminum incline board and the block. The block, as you can see here, has 4 sides. This is large felt, small felt, half the area. This is large wood. This is small wood. So we can do this one block for static friction for all 4 sides. Now, when we do it for part 2, we're only going to use 3 sides because touched by feel, the grain is not the same on the small wood as on the large wood. And it's hard to see on the screen, but touch me, by touch you can tell the difference. So what we have here is a board that I have hooked to this giant protractor so that I can measure the exact point at which things slides. So the first run is to get it up there and to see where it is. Then I'm going to back off by 2 or 3 degrees and go up slowly. That's because if you introduce any energy into the situation, it'll slide prematurely and you'll get an incorrect value for the static coefficient of friction. So let's go ahead and do that. Up, 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 past 10 degrees, past 12, bordering on 13, and it's begun to slide. I'm measuring from the bottom here. Now, once I've done that, I would go down to maybe 11, reset it at exactly the same spot, and go up a little slower. And I can get probably 5 good readings on this. Now, I could repeat this for kinetic friction by, let's say, lowering it to, I don't know, let's say 11, bringing it back to the same spot and tapping it, and see if it begins to move extremely slowly. And it doesn't, so let me bring it up to a little more, tap it, and believe it or not, it is moving just a tiny bit, but not enough for me to be sure. So if I press it up to, let's say, 11 and a half, give it a whack, and it was moving fast at first, but as you can see, it's still moving. So by measuring that angle, I could get the kinetic coefficient of friction.